Okay, so this topic is called combination of functions. And if you look at that top box up there, this box right here, what I'm talking about is what happens if you take two independent functions and you add, subtract, multiply, and divide. What impact does that have on this new function, and what impact does it have on the domain of the new function? Okay, so we're going to go through a couple examples and then look at sort of a graphical illustration of this. Okay, so the first thing we're going to do is identify f and g themselves, and then look at add, subtract, multiply, and divide each case and what that does to the overall domain. All right, so f of x is just plain old x. Okay, and there are no domain restrictions on x, so its domain goes from negative infinity to infinity. G of x is the square root of x plus 1. And so now we're looking at square root restrictions. So with square roots, we want to make sure the number inside the radical it stays positive, 0 or positive. So this is where we would do a sign test, and I would figure out where 0 would show up. So if x plus 1 equals 0, that means x would be negative 1. So at negative 1, I get a 0 in the square root. And then I want to sign test before and after. And what I'm curious about are where the positives and negatives are. So if I evaluate this at a negative 2, I get negative 2 plus 1, so I get a negative number in the radical, which we don't want. And if I put 0 in, I get a positive number, which means anything bigger than negative 1 is going to maintain positive. Okay. So our domain of G, I can have negative 1, because if I put negative 1 in, I get square root of 0, which we do know is 0. So domain of G starts at negative 1 and then goes all the way up to infinity. Okay, well, what about combining different operations on f and g and making a new function? So we'll start with f plus g. What if I just add these two together? Well, as far as simplifying go, there's really not much we can do. I mean, what you get is what you get. However, what about the domain of this combination? Well, the first function, f, can have anything it wants. G, however, can only have things bigger than or equal to negative 1. And it's got to satisfy both requirements in order to exist in the combination function. So our domain for the sum function would be bracket negative 1 to infinity. Okay, and you're going to find similar arguments for the subtraction, the difference. So x minus square root of x plus 1. If I take the x's and subtract, or the y values and subtract, what do I get? And the domain's going to match 100%. Same thing with product, x times square root of x plus 1. Okay, so yes, you have to think, another way to think about this is who shows up to the party. So if I took f and g and had them hang out together, what x values would have actually showed up because of f being there or because of g being there. Now f invites everybody, but g only invited the things bigger than negative 1, which is why these guys, the sum, difference, and product, aren't changing much. Okay. Where it gets interesting, or where we actually see a difference, is in the quotient. So and you have to pay attention, order doesn't matter here, so f goes on top of g, so we're going to put x on top and square root of x plus 1 in the denominator. Okay. Now we've got another rule that we can apply, because now we've got a fraction rule with a square root rule. We already know what the square root tells us. The fraction rule says can't divide by 0. Well, what's the one number that will put a 0 in that denominator? And that's at negative 1. Okay. So if I look at the domain of g initially, the only thing that we now add on top of what we've got is we can't include negative 1, but anything bigger than that's going to be a positive number, so we can include that. And so we get parentheses negative 1 to infinity. And then there we go. Okay, we can also do combining functions when actually looking at a graph. So instead of giving an equation, we can compare it to a picture or even a table. So in this case, we're going to practice looking at a graph of f and x, or f and g. Sorry. Um, and again, the hard part here is kind of twofold. You got to understand what the notation's asking you, and then you have to know where to look in the graph. Okay, so number 2 here we have f of f plus g. So I really want f of 2 plus g of 2. So I'm going to go up to my picture, and I'm going to look. When x is 2, what's y? Y looks like it's about 4. And then I'm going to go over to g. When g is 2, when x is 2 in g, what's y? Y happens to be 4 also, so coincidentally they're both 4. Then I'm just going to add them up. 4 plus 4 gives us 8. Okay, number 3, f minus g, so I want f of 0 minus g of 0. So I go over to the f graph, and I look when x is 0. Y looks like it's about 3. And I understand it's a little bit of an estimate, but we're going to go with 3. If I go over to the g graph, and I look at x is 0, then I get a y value of 4. So 3 minus 4 gives us negative 1. And then lastly, looking at the product here, so I want f of negative 3 times g of negative 3. So I'm going to go over here into the f graph, and look, when x equals negative 3, y happens to be 1. And when g is negative 3, and again, this is an estimate. It looks like, so I'm looking at this point right here, and it looks like it's 3. So 1 times 3 gives us 3. Okay.